Now, today we are going to do a parametric analysis using ANSYS workbench. So let's look at the problem description. So we're going to analyze a HVAC duct system in a car. So it means that we are going to simulate aircon system for our car. So what is HVAC? What is car aircon system? That today we are going to simulate this part, the duct that transfer all the cold air into the car cabin here. So we are going to look at the system of this green color component here, which is all the aircon, all the cold air will go into the inside the car and so on. So because if you look at this green structure, it is a symmetry object. So to save time in our simulation, we'll do symmetry simulation, where we will cut this green color aircon into half. And you can see on the left top corner here, we will have the structure of our HVAC system, the duct. So we start with the front. So the gray color, this is the air intake, where all the cold air was pumped into this section. And then the cold air, was diverted into a different section of the car. So the cold air will go into the gray color region, which is called air intake. And then there are a few valves, right? So you will go, and then one is go to the floor vents. So means the air will go into this section and then go to the floor to cool your feet. And there's a windshield vent. The cold air can also go to the windshield vent, which is on top of this one. Yeah, windshield vent. And there's a channel coming out from outlets. There are two outlets here. Yeah, there are two outlets here. In this case, they call it front HVAC duct. So where is this this outlet? Is this one? This is the front outlet. This one and this one is the two main component here. So we're going to simulate the flow inside this aircon duct here. So yeah, this is the big picture of our HVAC system. Again, the cold air go into here, and then you can either channel to the floor, or you can go to the front of the passenger seats. So in this simulation, we're going to change the parameter of the valve, the location of the valve, that it will show us the changes of temperature, pressure, and also velocity of the air inside the duct. So we have three valves here. So the first valve is over here. It will control the flow go towards the heat exchanger. So the air will go into heat exchanger and then continue. Second valve is will divert the air to the floor. This is the valve. It will divert the air to the floor. The third valve here, it will control the air to go to the windshield and the front seat here. So this is the third valve here. In our simulation, the air over here will enter the HVAC system at 310 Kelvin with a velocity of 0.5 meter per second through the air inlet here. So we have a parameter that we need to set. The temperature going here is 310 Kelvin with a velocity of 0.5 meter per second. We are going to have a motion constraint. For the first valve over here, this is the first valve. So the value of rotation, the valve of rotation here, we will limit to 25 to 90 degree for the first valve here. While for the second valve, we will also have constraint value. the rotation of the valve will limit to 20 to 60 degree over here. Then for the third valve here, we'll limit to 15 to 175 degree over here. That channel the flow to the front seat of the passengers. So when the cold air go into the inlet, and when the valve shut and the cold air go up there. So the evaporator load in this case, is 200 watt in the cooling cycle, and the heat exchanger load is 150 watt over here. So what you need to do is you need to go to the Moodle and download this file, Fluent Workbench para.wb pzec file in the Moodle. You download, and then we will start to add in a constraint to the ANSYS workbench.